Good morning, children. Today, let's start a new lesson, physical and chemical changes. Every day, you come across many changes in our surroundings. These changes may involve one or more substances. Have you noticed how seeds grow into trees? Making a sugar solution, making bread from dough, souring of milk, setting curd from milk, stretched rubber band. These all represent a change. Then what is change? The process in which there is a change in state, color, shape, size, property, chemical composition and structure of a substance is called change. Changes are of two types. They are physical changes and chemical changes. Physical change is a change in which a substance undergoes a change in its physical properties. Okay, it is a change in which a substance undergo a change in its physical properties. Then what are physical properties? Physical properties means the properties such as shape, size, color and state of a substance are called its physical properties. Okay? Properties such as shape, size, color and state of a substance are called its physical properties. If there is a change in any of these, we can say that this is a physical change. A physical change is generally reversible. In such a change, no new substance is formed. Let us go through more examples of physical changes. Take some sand and mix it in water. Would you be able to remove sand from water after they are mixed together? Melt a chocolate bar to liquid. Do you think you can solidify the same liquid to be a chocolate bar again? Let us do some activities. Take a piece of paper. Fold it to make a paper aeroplane. There is a change in its size, but we can unfold these pieces of paper back to its original size and shape. So it is a temporary change. That is, it is reversible in nature. Also in this paper, the chemical composition of the paper remains same. Cut a piece of cloth in 4 square pieces. Lay these pieces on the floor or a table so that the pieces acquire the shape of the original piece of cloth. Obviously, you cannot join the pieces back to make the original piece. But is there a change in the property of the paper? Now compare the size of one piece of cloth with the original piece of cloth. But properties of the cloth remains same. So this is a physical change. Let us do another activity. Take a chalk and crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Roll it to the shape of a piece of chalk. Then let it dry. Did you recover chalk from the dust? Yes, you will obtain the chalk. This kind of change is physical change. Changes are of two types, physical change and chemical change. In this module, let's study about the physical changes. When there is a change in physical properties of substances such as shape, size, color and state of the substance, which is called physical changes. Examples: melting of ice, vaporization of water, dissolution of sugar or salt in water. Take some ice in a beaker. Melt a small portion of ice, placing the beaker over a Bunsen burner flame. You have now a mixture of ice and water. Boil this beaker. On heating, ice changes into water. When this water is heated to 100 degrees Celsius, it changes into vapors. These vapors on cooling changes to water, and when the water is cooled up to 0 degrees Celsius, it converts into ice. So, in the whole process, water changes only in the state and chemical composition of water remains same. Let us do one more activity. Hold a used hacksaw blade with a pair of tongs. Keep the tip of the free end of the blade on the gas stove. Wait for a few minutes. Now you can observe the change in the color of the tip of the blade. Remove the blade from the flame. Observe the tip once again after some time. You can observe that the tip of the blade get back its original color. As color is a physical property, we can consider this change as physical changes. As you know, salt can be obtained by the evaporation of seawater, but the salt obtained in this manner is not pure. Pure substances can be obtained from their solution by crystallization. Take 30 ml of distilled water in a beaker. To this, add powdered sample of copper sulfate using a spatula. Stir the solution gently with a glass rod so that the powder dissolves. Add the powdered sample several times till a little of it remains undissolved in the beaker. Then add about 3 ml of dilute sulfuric acid to the solution using a measuring jar and gently stir the solution to make it clear. Place a filter paper in the funnel and clamp the funnel to the stand. Place a china dish under the funnel. The stem of the funnel should touch the wall of the china dish to avoid the solution splashing out. Pour the solution into the funnel over the glass rod and collect the filtrate in the china dish. The insoluble impurities are left over the filter paper. Heat the china dish in the sand bath till the solution is reduced to about 1/3 of its original volume. Stir the solution continuously with a glass rod. Transfer the hot saturated solution into the evaporating dish. Now place the evaporating dish containing the hot saturated solution in a tumbler containing water. Cover the dish with watch glass and allow it to cool slowly for some time. As the solution cools, deep blue crystals of copper sulfate separate and the crystallization will complete after half an hour. Decant the mother liquid carefully into a beaker. Wash the crystals 3 or 4 times with ethyl alcohol containing a small amount of cold water. Using spatula, place the crystals on a filter paper and allow it to dry. The crystals of pure copper sulfate are transparent and blue in color. So you have learned about the process of crystallization. That is, it is a process in which Large crystals of pure substances are formed from the solution. This is an example of a physical change. Okay, thank you.